All right, these are our notes for section P.4a, College Algebra. We are looking at polynomial expressions today, and just a quick review of our definition. A polynomial is a single term or the sum of two or more terms containing variables and whole number exponents. So we have several examples over here. Remember that your plus and minus sign separates your terms. So in this case, that's one term, that's a second one, a third one, and a fourth one. The degree of a polynomial is your highest power. If there's more than one variable, you actually have to add the exponents in each term. All right, standard form is when the terms are written in order from highest power down to lowest power. All right, and then we often name our polynomials by how many terms they have. So we call it a monomial if there is one term. We call it a binomial if there are two terms. And we call it a trinomial if there are three terms. All right, a couple other definitions. Constant is a plain number, just like a 6. So right here, this -7 would be a constant. A variable, typically we use x, but it represents an unknown number. And coefficients, those are the front numbers, the numbers in front of your variable. So if I had a term of 3x, 3 would be the coefficient piece of that. All right, we're going to look at adding and subtracting some polynomial expressions. The thing you want to look for here are to combine like terms. And remember, for things to be like terms, they must have the same variable and the same exponent. So in this case, we have a 9x cubed and a 13x cubed. We could put those together as 22x cubed. Then we could look at our x squareds. We have a 7 here, and we have a 2 here. We can put those together as 9x squareds. Our x's, we have a -5x and a -8x, so -13x. And then our constants, we have a 3 and a -6. That would add up to -3. All right, the next two are subtraction. Where most people make the mistake is that they forget to distribute this negative sign to all of the pieces after it. Everything in that next set of parentheses. So we're going to rewrite this one. Our first polynomial does not change. Our second polynomial, all our signs become opposite when we distribute that negative. So we have -2x cubed, we have +6x squared, we have +3x, and -9. All right, looking for like terms again, we have a 7x cubed and a -2x cubed. We can put those together as 5x cubed. We have a -8x squared. We have a +6x squared, which would give us -2x squared. We have a 9x and a 3x, which would add up to 12x. And we have a -6 and a -9 to give us -15. All right, go ahead and pause the video and try question C. When you're finished, turn it back on and check your answer. All right, distributing our negative. Nothing changes in our first parenthesis. Everything in the second parenthesis turns to its opposite, so positive 7x cubed, negative 2x squared, positive 5x, and negative 9. Combining like terms, we should have 20x cubed, negative 11x squared, negative 2x, and negative 8. All right, shifting to multiplying polynomials. This is where we need to use our distributive property or our foiling technique. The first one here is just a distributing. We want to multiply the 3x to the fourth to each piece inside. So 3 times 2 would give us 6. X to the fourth times x to the third. We add our exponents when we have like bases. So we have 6x to the seventh. Our next piece, 3 times negative 7 would be negative 21. X to the fourth times x would be x to the fifth. And our third term, 3x to the fourth plus 3 would be 9x to the fourth. Our next one, we can't use the foiling technique. Foiling is strictly for a binomial times a binomial, and we have a trinomial here. But it is just expanding on our distributive property. So we take our 2x and multiply it to each piece. All right, we end up with 2x cubed plus 8x squared plus 10x. Then we go back and we distribute the 3 to each of those pieces, which gives us 3x squared plus 12x plus 15. And notice that I lined up my like terms so that when I'm trying to group like terms together, they're all in a column. Combining those, I end up with a final answer of 2x cubed plus 11x squared plus 22x plus 15. All right, go ahead and pause the video and try question C. All right, multiplying our 5x to each piece gives us 15x cubed minus 25x squared plus 20x. Distributing our negative 2 to each piece gives us negative 6x squared plus 10x minus 8. And combining all of our like terms, we end up with 15x cubed minus 31x squared plus 30x minus 8. All right, shifting to binomial times binomial. This is our foiling technique. Foiling, remember, stands for first, outside, inside, last. It really is just distributing like we've just been doing. 3x times 4x would give us 12x squared. 3x times 5 would give us 15x. Insides, 2 times 4x would be 8x. And last, 2 times 5 would be 10. Typically, our middle terms match, so we end up combining those. 12x squared plus 23x plus 10. Go ahead and pause the video and do questions B and C. All right, checking. First term, we should have 15x squared. Outsides give us negative 9x. Insides give us 20x. When we combine those like terms, we end up with 11x. And then our last term, 4 times negative 3, should be negative 12. For question C, we have 28x squared as our first term. Outsides gives us negative 21x. Insides negative 20x, which adds up to negative 41x. And then our last term, a negative 5 times a negative 3, is a positive 15. All right, our last three examples, you will notice that our terms are almost identical except for that sign in the middle. In one, we have a positive, and one we have a negative. And when we FOIL those, we end up with our middle term dropping out. 5y times 5y for our first term is 25y squared. Outsides gives us negative 20y. Insides gives us a positive 20y, which cancel each other out. And then our last, the 4 times the negative 4, would be negative 16. This is called a difference of squares. We have a perfect square minus a perfect square, and it comes from this sum and difference pattern. All right, the only thing different with the last two are that our powers are a little bit higher, but we have the same process. 5a to the fourth times 5a to the fourth is 25a to the eighth. Insides and outsides will cancel each other out again, and then our last term, 6 times negative 6, is negative 36. Go ahead and pause the video and try the last one on your own. All right, checking, we should have 4y to the sixth minus 25. All right, and that is it for today's notes. Your assignment is on page 61. Numbers 1 to 39 odd, 91 to 95 odd, and 115 to 117 all.